Okay, let's keep going with solving systems of equations. And today we're going to be looking at solving them with graphing. So as you know, we have been solving with elimination, looking for the intersection point, which is an x and a y. And so we're going to move into the next method, which is solving them with graphing. So we're going to solve them visually and find our intercept. So let's go ahead and do a quick review of solving for y and graphing. That would have been from last semester. So remember, we're solving for y. We need y equals mx plus b. So when I'm solving for y, remember we need to think about if we're solving for y, what is actually happening to the y. So that's actually times 3 divide 3, and that's a positive 2x, which means I'm going to subtract 2x. So I always move the x value first, and then I'm going to divide by what is next to the y. So to move this positive 2x, I am going to subtract. So that's an additive inverse. That gives me 0. That goes away. I'm going to drop my 3y. And I notice that this 6 and this negative 2x, those are not like terms. One is an x, or a variable, and the other one is a coefficient. So they're just going to hang on to each other and drop. And of course, the x goes first because variables come before numbers. So right now, I now have my x on the other side. To move the 3, I am going to divide 3 times, and this is gone. Negative 2 over 3. Now, I know negative 2 over 3 is actually simplified as far as it's going to go. It is not going to simplify any farther than that, but I can always use my Desmos calculator to double check that. And if I take 6 divided by 3, I get plus 2. So I see from my equation that my m is negative 2 over 3 and my b is a positive 2. Okay, so to review real quickly how we graph, we always start with our y-intercept. And the y-intercept is on the y-axis, which means it's the up and down. So I'm going to start with my plus 2. That stands for the beginning or the starting point. So plus 2, 1, 2. I'm going to put my point. That is my first thing that I do. That's the b. Then the negative 2 over 3 tells me from that point, I'm going to go down 2 and I'm going to go right 3. So 1, 2, 1, 2, 3. I have my second point, and then I can draw my line. And we do want to try to make as good a lines as possible here. And you can see I'm really struggling making a good line today. But we want to make really nice lines because when we're actually drawing a system, we're looking for where they intersect. And since I need to draw an intersection, that means I need really good lines that actually go through the points. So you're going to want to make as many points as possible on your graph to kind of ensure that you have a really good line and you can see where the intersections happen. Okay, let's keep going. And let's take a look at the 3 different pictures or graphical images of our system. So we already know that we can normally come up with one solution. This is our norm, okay? Normally we're going to come up with an x and a y. But there's also the other 2 solutions. One of them is no solution, okay, which we've kind of talked about. And this one is when the lines are parallel. So the lines are not touching. Okay, the lines are not touching. So since I'm actually looking for an intersection point where they're touching, if they don't touch, there's no answers. So that is no solution. And the other one I have is infinitely many solutions. Infinitely many solutions. And what happens with that one is it's the same line. So I'm graphing one line on top of the other, and I can see that they're going to intersect the entire way. So there's more than one answer. So those are our 3 possible graphical images we're going to see, or models, when we are solving systems. Okay, let's take a look at an example of a system in real life and kind of figure out what the whole purpose of looking at something in a visual model would be. So I've got these 2 taxi cabs. I've got the yellow cab and the blue cab. And I see that they intersect at this point right here, which happens to be 3, 8. Okay, so the 3 is a miles, and the 8 is money. So let me think about this for a second. So I think, if I remember right, the intersection, the other name was equilibrium, which means equal. So at this point, this would mean that both the yellow cab and the blue cab are the same price if I'm going to go 3 miles. Okay? If I'm going to go 3 miles, they both cost the same price. It's going to cost me $8 no matter which taxi I take. Okay, so let's back up a little bit and let's go to 1 mile. Let's say that I'm going to ride the taxi for just a mile. I just have to go a little far down the road. If I come up, I see that the blue one is going to cost $3.50, or the yellow one's going to cost $3.50, and the blue one's going to cost just under $6. So we'll just go ahead and round it up to $6. So if I was going to pick a taxi to ride for just 1 mile, which one would be the cheapest? Yeah, you're right. It would be the yellow. That would be the cheapest. Okay. Well, what happens if I'm over here at 8 miles? Well, there's the blue one. That's going to cost $12. And here's the yellow one. And that's going to cost $17. So in this case, the blue one is cheaper. Okay. So what happens is this allows us to make a couple of statements about when I should take which taxi cab, or which one's the better deal. Okay. And it all comes back to the intersection point. So I see that the intersection point being at 3 miles, if I go this way, the yellow line is the lowest. So that means if I'm going to travel less than 3 miles, then I want the yellow cab. If I travel less than 3 miles, I want the yellow cab. Well, then the opposite would be true. If I'm going to travel more than 3 miles, and that is, those words would be greater than, that's the math word, I want the blue cab. I want the blue cab. Okay. Sorry about my dog barking in the background. That's what happens when you're making videos at home. All right, let's go ahead and see if we can graph these lines and look for the intersection. Let's start with the first one. So my M is -5/3, and my B is +3. And remember, when we're starting with our intercept, that is always going to be on this line. Okay, so that is where the B goes. So let's go ahead and put that point there. So +3. 1, 2, 3. That's up 3. Okay, so this is negative. So that means I'm going to go down, or I'm going to go to the right. 1, 2, 3, 4, 5. 1, 2, 3. And again, I'm going to draw a line. Try to make a good line, which means I'm going to have to tweak this a little bit to see if I can line it up a little better. That's not too bad. You can see how using a ruler would definitely be easier than me doing it on the computer. Okay, let's do the other one. So our second one is y equals 1/3 x minus 3. So my M is 1/3, which means it's a positive slope, and my B is -3. So I'm going to start down at -3. 1, 2, 1, 2, 3, negative. I'm going to go up 1/3, up 1/3. And you can see that in this case, I can also go down 1/3, the opposite direction. In this case, my lines actually intersect in a very easy spot because I actually see that that first point I make is actually on the other line. So I know that my intersection point is easy to find. It's right here. So this is my solution. And remember, this is an X and a Y. So I need to figure out my X value. My X value, which is my sideways value, is 1, 2, 3. So I know that's a 3. And I have to go down to get to that point. So that would be 1, 2, a negative 2. Okay, let's try another one. Y equals 4x plus 3. So my slope, remember, that's 4 over 1, and the b is plus 3. So I'm up at 3. And notice how I cannot go up 4 because I'm out of graph. Well, if I'm supposed to go up and right, the opposite would be down and left. Remember, this is a positive slope, so the line has to be going in this direction towards the plus sign. So I need to make the opposite. So 1, 2, 3, 4, and right 1. And I can do it again. 1, 2, 3, 4, and right 1. I'm going to go ahead and draw that line. We'll see if I can get a decent one. First shot. Yep, that's not too bad. All right, let's do the other one. Okay, well, what does this mean if I have a negative in front of that? Well, if I remember right, that means that's a negative 1. So negative 1 over 1 would be my slope, and I have a b of negative 2. So here's my yellow line. I'm going to start at negative 2. I'm going to go down 1, right 1, down 1, right 1, and I'm going to do the opposite. Give myself a few points, and I can see right where my intersection is. Because again, it falls on top of the other line. So my intersection point is very easy to locate, which is my solution. My solution is right here, where the two lines cross. And let's try to figure out our x and y. Well, I went over 1 to the negative, so that's going to be a negative 1, and I'm down 1. So that solution is negative 1, negative 1. Okay, let's do a couple more. We got these two to do, and then we'll be working on homework. All right, so let's do negative 1/2 minus 1. Again, my m is negative 1/2. My b is negative 1. So negative 1. Down 1, right 2. Down 1, right 2. And I can again do the opposite. Up 1, right 2. Up 1, right 2. And I have my first line. Okay, let's see if we can get our second line. So b is negative 4, and our m is 1 over 4. So here's negative 4. If I'm going to go up 1, right 4, up 1, 1, 2, 3, 4, I see again it falls right on the line. Opposite, down 1, left 4. It's always really nice when they fall exactly on another point. It makes it easier to find your solution. So my x value is a 4. 1, 2, 3, 4. And to get to that point, I'm going down 1, 2, 3. So that means that is a negative 3. Okay, now this one is interesting because I see that I have this y equals 1. I'm going to go ahead and start with the bottom one because I know how to graph that one. Negative 5 over 2x plus 4 is my b. So positive 4. And down 5, 1, 2, 3, 4, 5, and there's 2. I'm not going to be able to graph any other lines or any other points on that one because I just don't have enough space. So I'm going to go ahead and draw my line in there. See if I can line that up a little bit better. Okay, now I want you to think about this other line for a second. So I don't see any x's. So since there's no x's, that would mean that's a 0x. So I have a 0x minus 1. And remember, a 0 is a horizontal line. So I'm at negative 1, and I'm drawing a horizontal line. Horizontal line, so a 0 slope, which means I'm going straight across at the negative 1. So where is my intersection this time? Well, I'm 1, 2 over with a positive 2, and I'm down a negative 1. So my solution is 2, negative 1. Okay, so you're going to be doing some graphing today on an activity on Desmos to kind of make sure that you are good to find your solutions. Draw good lines. Make sure you make multiple points as you're working so you can easily find your answers. And reach out to us if you're having any problems. Have a good day.